Hello friends, welcome you all on Amazon Academy. How are you all? I read all your comments. If you follow this crash course till 14th of March, will we surely be get 90 plus marks. Nothing is sure beta, but obviously we have researched a lot and we came to know that if you actually seriously, religiously prepare for these 19 chapters, you will might get 90 plus marks. Hello guys. So let's start. So we are going to study GOC, General Organic Chemistry, lecture 1. Today we are going to study inductive effect, mesomeric effect and application of resonance. This is Ashutosh Gautam and these are my credentials. Live lecture, best practice are there. You need to behave properly, never spam or use my doubt section to ask doubt related to class without disturbing the other student and teachers. Now start with the system requirement. Currently not supporting Safari and Edge, and you need to have Android version 6 or above, and 5 Mbps speed is enough to continue. Okay, fine, let's move. So this crash course is all about what making you prepare for getting maximum marks with minimum efforts. So actually we made a research in which 9 out of 91 chapters we need to prepare only 45 chapters. Out of 45 we will prepare 19 chapters before March attempt, and between March to April we'll prepare for the next 26 chapters remaining. So if you prepare these 19 chapters, you can achieve up to 90 marks in the March attempt, and till April you can achieve up to 190 marks if you prepare remaining 26 chapters. So this is our research of which we conducted on about 62 JEE Mains previous papers. So we are going to study in March electrochemistry, coordination, GOC, aldehyde, ketone, carboxylic acid, some basic concept of chemistry, equilibrium and hydrocarbon. Remaining all these chapters will be taught between March to April. So let's start, guys. Today we are going to study degree of unsaturation, which is first and foremost topic of today. Next is types of bond cleavage, types of electron displacement effect, inductive effect and its application, resonance and its application like aromaticity, and mesomeric effect and resonance energy. So these are the topics we are going to study. So let's start with degree of unsaturation. Firstly, what is degree of unsaturation? Degree of unsaturation is number of hydrogen molecules required, number of hydrogen molecules, mark my words, molecule required to convert a cyclic unsaturated compound into acyclic saturated. This is the very important topic, degree of unsaturation. Let's start with simple examples. CH2 double bond CH2. What would be the DO of degree of unsaturation of this? How many moles of hydrogen required to convert into acyclic saturated compound? What degree of unsaturation would be 1, because 1 mole of H2 would be required to convert into CH3, which is acyclic as saturated compound. Now let's start with the ring. What would be the DO of this? How many moles of hydrogen molecules required to convert into acyclic saturated compound? Now let's move to the next part of it, that is formula. which we actually study in the books, but we are not going to follow that formula. We have our own formula. Yes, degree of unsaturation would be 1, because the formula of it is C6H12, which will be converted into C6H14. So 1 mole of H2 molecule would be required or sufficient to convert into a cyclic saturated compound. So we need to calculate the number of pi bonds and number of rings in any given compound if structure is given. Let's have an example. If it is asked what would be the DU of benzene, how many H2 molecules are required to convert into a cyclic saturated, and the answer would be what? Yes, 4. How to solve it? 3 pi bonds and 1 for ring. This is it. Now it would be asked like this. They will test your resonance also abilities. What would be the DU of this? How many moles of H2 required to convert into a cyclic saturated compound? No, it would not be 8, my dear friends. Firstly, let's draw it in the other way. If I'll do like that, you can easily find out now that number of pi bonds are 5 and number of rings are 2. That means overall together 7. You would be 7. So you need to draw pi bonds, then only you can answer. Let's have another example. What about this? What would be the DO of this? Let's firstly write your name before answering. Like, you should answer like this so that we can connect with each other. KP. Yes, my dear. 10. Let's draw it in the other way. You need to drop double bond at every alternate position. I'll come to know the DU would be what? 7 plus 3. That means 10. If formula is given. If what would happen if formula would be given? Formula, that means if formula is like C5H5N is given, what would be the DU of this? You need to calculate this through some formula like C plus 1 H plus X minus N divided by 2. This is the formula which is written in the books, but we are not going to follow this when formula is given. We have our own formula which shows DU equals to sum of contribution of each atom divided by 2 plus 1. So this is the formula of DU. Now first thing comes, what is the contribution of each atom? So let's start with an example, C5H5N. Let's have the contribution of each atom. What is the contribution means? Contribution means valency minus 2. Valency minus 2. Let's have an example. What would be the contribution of carbon? Valency 4 minus 2, that means 2. What would be the contribution of boron? 3 minus 2, that means 1. What is the contribution of H? 1 minus 2, that means minus 1. What is the contribution of X? Friends, the contribution of X in our life is always negative. Contribution of X in our life are always negative. Don't you think so? This is the contribution of each atom. You need to calculate like this. Like carbon has contribution of 2 into 5, that means 10. Hydrogen has contribution of minus 1 into 5, that means minus 5. Nitrogen, valency 3 minus 2, that means contribution is 1 plus 1 divided by 2 plus 1. This is the formula which we are gonna use. And what would be the DU of this? Halogen. X means halogen. Yes. What would be the DU of C5H5N? Now you can calculate like this. 4. Yes. Let's now this formula is applicable to each and every molecule which we want, because this formula will not help us when boron, aluminium, phosphorus and sulfur like compounds again atoms are given, but this of our own formula will help us out in any possible formula given. Let's have an example. Let's have some difficult example like C6. Let's have C7 H8 Cl N3 O3 and sulfur S2, where valency of sulfur is 6. Now what would be the du of this compound? Calculate. Calculate. C7H8 Cl N3O3 S2. When valency of sulfur is given 6. Sulfur can behave differently as per their valencies. It can show valency of 6, 4 or 2. So contribution can be differ. Contribution can differ. Like 6 minus 2, the contribution would be 4. 4 minus 2, the contribution would be 2. 2 minus 2, the contribution would be 0. Calculate, my dear friends. What would be the DO of this? How to calculate? Contribution of carbon is 2. That means 7 2s are 14 minus 8. Halogen minus 1. Nitrogen contribution is 1 plus 3. Oxygen contribution is 2 minus 2 0. Sulfur contribution sulfur would be valency is given 6. That means contribution would be what? 4. 4 2s are 8. Divided by 2 plus 1. Answer would be what? 9. So this is the best way to calculate degree of unsaturation, which is very important concept. Let's have one more example. C6, and you wanna calculate this. What would be the DO of this? Calculate. Yes, Shreyas 9, Shriram 7. Let's review. Shriram, please review it. AG says 9. No, it was of the previous question. Answer it. What would be the DO of C6H7BO2? Then we'll move to the next topic, which is bond cleavage. 4. Let's calculate it. PC says 4. Shriram says 4. Chirag 4. Yash 3. LL says 4. Shreyash says 4. Okay, let's calculate it. Carbon 12 minus 7 boron, that means plus 1 divided by 2 plus 1. Answer would be what? 4. So this is the best way to calculate what? Degree of unsaturation. Even though if structure is given, you can convert it into the formula and then apply the formula. Like in this compound, what would be the DU? DU would be केपी बेटा, तूने तो पढ़ लिया ना लास्ट क्लास में, ये साउथ वालों के लिए है. DU would be 5. Yes, calculate it, convert it into formula like C8H8. Now apply it. C8H8 means 16 minus 8 divided by 2 plus 1. The answer would be what? 5. Yes, the answer would be 5. If you will calculate rings, the answer can be different like 6. That would be wrong. So this is the best way, without making mistake, convert it into chemical formula and then apply the formula, R formula. So this is the way to calculate degree of unsaturation, which is very important concept. Now let's move to the next topic, that is types of bond cleavage. We are going to start general organic chemistry from here. Types of bond cleavage. There are two types of bond cleavage. There are two types: homolytic bond cleavage and heterolytic bond cleavage. What is homolytic bond cleavage? When bond break, as it forms, one electron was given by A and the other was given by B, and it breaks like that only, and it forms what? Radicals. These are called very reactive species. These are very reactive species, and they are called as free radicals. Considering these A and B are carbon, we can say these are carbon free radicals. The smallest example of carbon free radical is CH3 dot. So if bond breaks homolytically, radicals are formed. Similarly, in case of heterolytic cleavage, let's break it in heterolytic way. Heterolytic way, that means electron shifts towards more electronegative atom. Let's have an example. We are considering here electronegativity of B is far more than electronegativity of A. So when bond breaks in presence of polar solvent, it convert into A plus and B minus. Considering both are carbon, we can generate carbocations and carbanions. The smallest example of carbocation is CH3 plus, and the smallest example of carbanion is CH3 minus. So these are three intermediates which can be formed during the reactions. These are carbon free radicals, carbocation and carbanion. Let's have an example. Let me ask a question. Carbocation, carbon free radical, and carbanion. This is A, B and C. Which of the following is electron rich with complete octet? इसमें से कौन सा है which is electron rich and its octet is also complete? What would be your answer? So your answer should be like this. Let's calculate the number of electrons. So the answer is like C. Okay, fine. So this is it. The 6 electrons in the central atom, here 7 electrons in the central atom, and here 8 electron in central atom. So these are reaction intermediate which form during the reaction, and stability of these reaction intermediates decides the rate of reaction. So the next part of discussion is how to stabilize reaction intermediate so that we can compare the rate of reaction. If we can compare the rate of stability of intermediate, we can compare the rate of reactions also. So let's try to understand the way to stabilize carbon-cation, carbanion and free radical. Let's have an example. CH3 plus, which is carbocation, and CH3 dot, which is free radical, both are electron deficient species, and CH3 minus is electron rich. All are very unstable species. Both want to convert into a neutral species which has octet complete. So anything which will help to make them reach here will stabilize them. So let's answer me, who can stabilize carbocation and carbon free radical? Carbocation and carbon free radical is directly proportional to what? Electron donating groups, A, and B, electron withdrawing groups. Let's answer it. Carbocation and carbon free radical both are electron deficient. They want to convert into a neutral octet complete species. Who will help them to achieve this position, neutral with octet complete? A, electron donating group, or B, electron withdrawing group? Yes, all have answered. Write your name first and then answer, guys. Electron donating group or electron withdrawing group? This is like Garib, poor person, and this is like rich tycoons. They are like Ambanis. That means electron donating group will stabilize the carbocation and carbon free radical, and vice versa. That means carbanion is stabilized by what? Electron withdrawing groups. and inversely proportional to electron donating groups. So this is it dosto. Let's continue. Now we are going to study the things what are electron donating effects and what are electron withdrawing effect. So now we are going to study electron displacement effect. So there are two types of electron displacement. One is permanent electron displacement and the other one is temporary. We are not going to study the temporary one. We are going to study only permanent one here. Permanent is first is inductive effect. Inductive effect is called as what? I effect. Next one is resonance effect, or otherwise called as what? Mesomeric effect. Yes, you all are right. Otherwise called as R effect or M effect. Next is hyperconjugation, which is called as what? H effect. And lastly field effect. This we're gonna study in GOC2. Today we are going to study inductive and resonance. So let's start the topic inductive effect. What is inductive effect? A. It is polarization. Answer. Polarization of sigma bond. Or B. It is polarization of pi bond. What would be your answer? What about nomenclature? Leave it, guys. We are not going to discuss this topic, nomenclature here. You can study there, study on. So inductive effect is polarization of sigma bond or polarization of pi bond. This is, yes, this is polarization of sigma bond towards more electronegative atom. Yes. It is distance dependent effect. It is distance dependent effect. Yes, it is distance dependent. Let's have an example. Suppose CH3, CH2, CH2 and F. Now what would be the electronegativity of fluorine? 4. So electron shifts towards fluorine, making it partially negative, which makes it partially positive. Now this carbon is electron deficient. It will look for electron from carbon 2 and which make it again positive and partial positive charge. This. Now let me answer some more things. This is carbon 1, carbon 2 and carbon 3. Please tell me the order of electronegativity of carbon 1, carbon 2 and carbon 3. A. What would be the order of electronegativity? C1 has the highest electronegativity, then C2 and then C3, or the second one, C3 would be the highest electronegative carbon, then C2 and then C1. What would be your answer? Depending on the electronegativity. 3 to 1. Electronegativity. Electronegativity is tendency to attract electron. Sanjana says C1, C2, C3. हाँ भाई वो है, वो ट्रिक है. It is there in YouTube. Nitrogen and its compound. Yes. So the answer would be what? Electronegativity is tendency to attract electrons, and the one which is having least number of electrons would be having highest electronegativity. That means carbon 1 has highest partial positive charge because it is attached directly to the most electronegative element of this earth, fluorine. So this is most electron deficient carbon. So the electronegativity of C1 would be the highest, then C2 and then C3. So A would be the answer, guys. Let's move. This is inductive effect. Key points. You need to learn this trick in this page. Electronegativity order. This is my trick. Let's have fluorine, This can solve 100 of questions. Electronegativity is 4. 3.5. Electronegativity, what is 1? This is sp1 carbon. What is 2? This represent sp2 carbon. What is 3? This is sp3 carbon. Now what is the electronegativity of sp carbon? Shockingly, it is 3.25. Nitrogen, electronegativity is 3. sp2 carbon, 2.75. And what is the electronegativity of sp3? 2.5. Mark my words, if electronegativity of nitrogen, if we want to increase the electronegativity of nitrogen over this sp carbon, we need to change the hybridization of it. If nitrogen become sp2, the electronegativity of nitrogen become higher than the sp carbon. Mark my words. I'll ask this again in this class. Okay, let's move. There are two types of inductive effect, plus I effect and the other one is minus I effect. This is the order you need to learn. You need to learn that SiH3 has more electronegativity than the carbon because the electronegativity of silica is lesser than the carbon. Next important thing you need to learn is TDH. Tritium has higher plus I effect than deuterium and than the hydrogen. Why is it so? Hydrogen has the longer bond length compared to the CT. So as it is distance dependent effect, tritium gives more number of electrons than the hydrogen because it is distance dependent effect. Electronegativity of tritium and hydrogen is almost same. So that depends on the bond length. So T has the highest electronegativity, highest donating effect among all these isotopes. Hydrogen is considered as reference point. So inductive effect of hydrogen is considered as shunya, 0. Secondly, this is the order of minus I. You can look here. Nitrogen, which is sp2, because of its more electronegativity than the sp carbon, it comes before the Cn. Similarly, positively charged species withdraws more compared to the neutral one, so they come first. The only exception is this. Nr3 is more electronegative than the NH3. You need to mark it important. Then CHO, COO and C double bond OR, F, Cl, Br and I. This is the one which I'm not going to explain now. We need to learn it. Let's move to the part of it, stability of reaction intermediate. How to compare the stability of reaction intermediate? Let's move. Suppose stability of carbocation and carbon free radical both are electron deficient species. Electron deficient, directly proportional to plus I, and carb anion is directly proportional to what? Minus I. You need to consider it. Now next thing you need to remember is distance, number, power effect before solving the things. This is you need to consider, and you need to answer it in sequence only. First you will look for distance, then the number and then the power. Let's have an example. Question number 1. Compare the stabilities. Compare stability. Guys, get ready to answer first. Compare stabilities. A, NO2, B, NO2, C, A, B, C. What would be the order of stability? P, A, then B and then C, Q, C, then B and then what would be the order of stability? First you look for what? Distance of the group. If distance of the group from the negative or positive charge are same, then you look for number of the groups, and lastly you look for power of the group. So K, you answered C, B, A, that means P, Q. Dhanush says P, Agastya says P, Dhruv says A, B, C, A, Ayushman says A, Q, A means I think Ayushman. Gigi says P, P and Q, PQ, PQ, PK. Let's try to understand. Firstly, you need to understand that negative charge is stabilized by negative, matlab minus I. Positive charge is stabilized by positive, that means plus I. So this is negative charge that gets stabilized by minus I of NO2, which is very close, and it is getting far and far away. Now, as per this question, this withdraws more compared to this, as inductive is distance dependent effect. So what would be the answer? The answer would be what? P. P withdraws more compared to the B. Sorry, A withdraws more compared to the B and C. So the charge get decreased. If it is withdraws more, charge get decreased. Charge decreases. That means stability increases. Charge is inversely proportional to stability. Considering this, so we don't consider M effect. There is no M effect here. There is no resonance here, guys. कोई resonance है ही नहीं. Let's have an example. Example number 2. Look for D and P. Firstly distance, then number, and then power. A or B, which is more stable? First you look for distance of group from the positive negative charge, then the number. More the number of groups, more would be the effect. A. Anjali says A. AP. Okay, A. So firstly we will look for distance of the Cl or F is same from the negative charge, so we'll discard it and we'll look for number. 2 minus I of 2Cl, which is weaker, as higher compared to the minus I of fluorine, which is stronger. That means you look for number only. So this would be the answer. And lastly you look for what? Let's have an example of power also. Negative charge, and this is NH3 plus, and this is NR3 plus. It's very important, dosto. You get confused into NR3 and NH3 plus. What would be the stability? Let's take it A and B. What would be the order of stability? Considering the exception, my dear friends, you need to consider the exception. Which of these two has higher electron withdrawing effect? Let's get back to the order. You can look here. NR3 has relatively more minus I compared to the NH3 plus. So considering this, you need to answer now. Minus I of NR3. Yes, EK says B, AB says B, AY says B. Please write your name in the chat box like this, Ashu, and then answer like this, B. Okay, so answer would be what? B, because minus I of NR3 is higher compared to the NH3 plus. So this would be the answer. Let's move to the next part of it. Some more examples of reaction intermediate. This is very important one. A or B, which is more stable? I mean, this is like this in other way. Anjali says B, Gaurav says A, JB says B, GT says B. It's very, very, very important question. Suraj says B, JB says B. Okay, let's try to solve it. Firstly, you need to have a knowledge like percentage S character is directly proportional to theta and directly proportional to what? Electronegativity. This is the Brahmastra you should keep in your mind. Percentage S. Let's have an example. CH3 double bond CH and this is triple bond CH. This is sp3 carbon, this is sp2 carbon, and this is sp carbon. Percentage S of this is 25%, 33%, and this is 50% here. Let's move to the electronegativity part. Electronegativity of sp3 carbon is 2.5, 2.75, and 3.25. Let's move to the theta. Sp3 means 109, 120, and 180. That means this Brahmastra is proved correct. Percentage S is directly proportional to theta, directly proportional to what? Electronegativity. है ना? बोलो 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 सर CH2. हाँ CH2. Yes. So let's try to understand this lone pair, the orbital of this lone pair. This is angle 60, which need to be what? 109.28 minute, or in case of ammonia it should be 107. So these two bonds should be 107, which is 60. So about 49-degree angle strain. So the angle increases here about 114 degree. This theta, which should be 109, is now 114. So theta increases, that means percentage S increases, that means electronegativity increases. That means this orbital has relatively more percentage S character, more electronegativity. That means the tendency to hold these lone pair is relatively higher compared to the any sp3, any standard sp3 orbital. That means if theta increases, percentage S character increases, electronegativity also increases. So we can say the answer would be like this. So can we solve it by the resonance? How can you solve in this example through resonance? There is no resonance at all. How did we get 114? Practical data. This is practical data which is given in the book. Because the angle decreases here somewhat, the angle which is decreased will get distributed in all these bonds. Okay. So this is stability of intermediate. Let's move to the next application of inductive effect, that is acidic strength. What is acidic strength? How you will compare through inductive effect? So this is the point. Acidic strength is directly proportional to what? Stability of conjugate base, which is generally negatively charged. You already understood that this is conjugate base, would be negatively charged, and negatively charged species directly proportional to minus I and inversely proportional to what? Plus I. So acidic strength is directly proportional to what? Minus I and inversely proportional to what? Plus I. So this is the point which I want to make. Remove H plus, form a conjugate base, compare its stability, to get acidic strength order. Let's have an example. HF, HCl, HBr, HI. These are the acids. What are the conjugate base of all these acids? H plus. Remove H plus. this would be F minus, Cl minus, Br minus, and this is I minus. Compare the stabilities of these four conjugate base which are negatively charged. Can anyone compare the stability? Which is the highest stable negative charge here? F minus, Cl minus, Br minus, or I minus? What would be the order of stability of conjugate base? F is very small, so negatively -1 charge is very concentrated, whereas I is very large size, so negative charge get distributed over this large surface of iodine. So charge will be felt less in fluorine or iodine. What would be the order of stability? F minus, Cl minus, Br minus, I minus. Charge density decreases, stability increases. Considering this point in the mind, what would be the order of stability? The order of stability would be what? I minus, because charge density is minimum, then Br minus, and then Cl minus, and then F minus. That means the order of acidic strength would be Hi, HBr, HCl, and HF. Yes, Shiansh. Yes, AG. Very right, very correct. So this is the best way. Remove H plus, form a conjugate base, compare its stability, and to get the acidic strength order. Let's have an example. You will answer now in the similar way. First one is this. What would be the most compare the stable acidic strength of all three? Key. Let give me the answer options. What would be the answer? Compare the acidic strength of all these three acids A, B, and C, considering D and P. Chirag says ABC, 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 ABC. Okay, Prince says P. Okay, so there are two weak effects. As we know, distance, number, and then power. Distance of fluorine and chlorine are same. Then we'll look for number. Minus I of 2Cl would be more compared to 1 fluorine. That means minus I is needed to increase the acidic strength. That means very correct. The answer would be what? P. That means firstly A, and then B, and then C. So we'll look for D and P here also. Let's have one more example to understand things in a better way. Write the correct order of acidic strength here. This is A. Write in the chat box with your name. This is B. And this is C. What would be the correct order of acidic strength? ABC is given. Dhanush says CBA. CBA, angular strain more in A. There's no angular strain. Gaurav says CBA. LU says CBA. CBA, 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 CBI. Let's try to solve it. Carboxylic acid, carboxylic acid, carboxylic acid. It has one fluorine here. It also has. So the effect of fluorine and fluorine would be same. So you can cancel it. Let's move to the other carbon. It has a fluorine. It also has effect get cancelled. The remaining fluorine will show the resultant effect, and considering these remaining fluorines, we can answer that this would be, this shows more near effect. That means minus I of this fluorine would be more compared to this, and that means answer would be C, B, and then A. Very 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 good. KP मेरे दोस्त, हिंदी मीडियम इंग्लिश वाले हैं अपन लोग, तो जो आज डीपीपी मिली है वो आपको नेक्स्ट क्लास में करके लाना है, यहाँ डिस्कस नहीं कर सकते. क्लियर. लेट्स मूव टू द नेक्स्ट पार्ट ऑफ इट. एक और सवाल अपन कर लेते हैं. एसिडिक स्ट्रेंथ. कंपेयर acidic strength. This is A and this is B. What would be the order of Ka1? Ka1, what is Ka1? Acid dissociation constant 1. A pinch of Spanish. Very good. Kindly focus on class. Yes, you should. So what would be the order of Ka1? Ka1, that means removal of first H plus. If you remove this first H plus, minus I of this carboxylic acid will start working. If you remove this H plus, the minus I of next group, which is, let's make it carboxylic acid, would be less compared to, because the distance increases. That means minus I of this carboxylic acid would be higher. So the answer would be A greater than B. So this would be the final answer. Let's move to the next part and let's make a Brahmastra which can solve all the problems now. Depending on the acidic strength, considering inductive effect, acidic strength is directly proportional to what? Stability of conjugate base. Directly proportional to what? Minus I. Inversely proportional to what? Plus I. या फिर directly proportional to what? Electron withdrawing groups. Inversely proportional to what? Electron donating groups. Secondly, considering this conjugate base stability, we can say the acidic strength is directly proportional to the concentration of H plus. That means concentration inversely proportional to the pH. Directly proportional to acid dissociation constant. That means inversely proportional to pKa. That means directly proportional to pKb. That means directly proportional to pOH. So this is the Brahmastra we were talking about, which can solve all your problems. Mark it star. Got my point? Let's move to the next part, considering acidic and fusion. Which of the following represent conjugate acid base pair? Which of the following represents conjugate acid base pair? A. H2O O minus 2. B. H2O OH minus. C. H2O H3O plus. D H2O or H minus. Answer it. Which of the following represent conjugate acid base pair? This question may or might be multiply correct. Conjugate acid base pair differs with 1 H plus. Conjugate acid base pair differs with 1 H plus only. That means this cannot be the answer. Sanya says BC, RS says BC, AK, DG. That means the answer would be what? B and C. 1 H plus difference. It has 1 H plus difference. It is altogether different, and it shows 2 H plus difference. So this would not be the answer. So answer would be what? B and C. Let's move to the next part of it. This is basic strength. We can conclude the basic strength considering these points. We can answer the Brahmas for basic strength also. Basic strength is directly proportional to what? Very importantly, when we are talking about the basic strength in the organic chemistry, that means we are considering what? More like Lewis base. So if I say base in the organic chemistry, that means you will understood it as Lewis base directly proportional to lone pair donating ability. Lone pair donating ability. In other beautiful ways, we can say unstability of lone pair. Mark my words, unstability, not stability of lone pair. Let's have an example to understand it. What would be the, let's have an example of this. The order of decreasing basicity in or full halide. Let's have an example and answer it. What would be the order of basicity? Basicity means instability of lone pair. Concentrate in the class, my dear friends. Instability of the lone pair. Suraj says C, Priyan says C, Chirag says C, Agat says A. Instability. What would be the order of stability? We have already covered it. That means this is the order of stability because of decreases charge density. So this would be the order of basic strength. That means very correctly you all answered C. Very importantly, instability of lone pair donating ability directly proportional to what? If I want to donate, that means some electron donating group should be present with me or on me. Directly proportional to plus I, that means electron donating group. Inversely proportional to what? Electron withdrawing group. Secondly, directly proportional to the concentration of OH minus, inversely proportional to the concentration of POH, directly proportional to the concentration of pH, inversely proportional to the concentration of what? H plus. Next, directly proportional to the Kb, acid dissociation constant, inversely proportional to pKb, directly proportional to pKa. So this is the concept map which can help you to answer all the questions. ठीक है ठीक है ठीक है. I corrected it. Electron donating मेरे भाइयों. ठीक है, मैंने गलती मान ली. तुम हारे मैं जीता. नहीं नहीं, मैं हारा तुम जीते. Let's start with the questions. As I've told you some important things, compare basic strength of the following. Compare acidic basic strength of the following. F minus OH minus this NH2 minus, it should remind you some important trick which I have covered earlier. What would be the order of this? A, B. Compare the basic strength. pK is minus log of Ka. Like pH is minus log of H plus. Similarly, Ka is minus log of pK is minus log of Ka. Acid dissociation constant. Order. Compare the basic strength order. Basic strength means instability of lone pair. Instability of lone pair, my dear friends. Instability, not stability. Instability. Instability of lone pair, not stability, my dear friends. You all are answering stability order. As per what? Electronegativity 4. This is oxygen 3.5. sp carbon is 3.25. This is 3. This is 2.75, and this is 2.5. So negative charge is more stable on 4 electronegative 4. Electron holding tendency would be more of fluorine, so it can hold the negative charge better. That means negative charge would be more stable on fluorine compared to the oxygen and then sp carbon. So this is the order of what? Stability. We don't want to stabilize the negative charge, we want to make it unstable so that it can be donated. That means answer would be B. That's why this trick is very, very, very important, which is called as formula 1 N23. The trick to remember is formula 1 N23. Formula 1 N23. Whereas FON 1 is sp carbon, nitrogen, and this is sp2 and this is sp3. So this is the best way to answer, my dear friends. I have already covered this beautiful concept of relative basic strength of amines previously. Go and check out on YouTube. Topic: organic compounds containing nitrogen. Go and check out. This trick says you or we are thief, that means chore. It has Dhoom movie involved into it. It has bank robbery involved into it. To remember what? Relative basic strength of amines. Go and check. Channel name is what? Amazon Academy only. Go and check the YouTube channel of Amazon Academy. Find this lecture, and in the starting of this chapter you will get the relative basic strength trick. Abhi nahi jana hai, baad mein jana hai. Let's have an example question. Compare basic strength. Basic strength in that inversely proportional to what? Electronegativity. Considering this, what would be the answer? A or B? You channel name is what? Amazon Academy only. What would be the answer, guys? Compare basic strength. Anya says B is greater than, Chirag says B, Kuhuk says B, Prince says B, JB says B, GM says B, Dave says B. Okay, so answer would be what? B. This nitrogen has lone pair, but it is sp2 because it is doubly bonded nitrogen, whereas this is sp3 nitrogen. That means sp3, that means electronegativity is less, that means electron holding tendency is less, that means it is more able to get donated. That means basic strength would be like this. Now I'll ask the Same question again and again. This is very beautiful question now. We have already discussed this. Legion can answer here. Intelligent persons can answer. Let me remind you a thing which is related to this. This is related to this. Now you can answer. Which is more basic? Very beautiful question. Very interesting one. Basic strength, that means lone pair donating ability. We have already discussed this lone pair. This angle is 114 around. We have already discussed, my dear friends. So that means theta is more. That means percentage S would be more. That means electronegativity would be relatively higher. Now you can answer it. Because electronegativity of this orbital is higher, that means this would not be donated as easily as it would be. That means answer would be this, unstability. This is a very beautiful question, friends. Let's move to the next part of it. Let's compare the one more question. Anyone can compare this? Compare the basic strength of this with this. A or B, which is more basic? And what would be the reason? Write in the chat box. Which is more basic and what is the reason? KU says A. And what is the reason? CH says B. Let's. B is sp2. Bridged. So what? If it is bridged, so what? It can donate its lone pair. Yes, it can donate because it will be sp3. There is no Brett's rule here because Brett's rule is applicable on the atom of bridged which is becoming what? sp2. This is not sp2. This is sp3. This is also sp3. Both are sp3. No one is sp2 here. No. My dear friends, A is more basic than B because of no ring flipping. There is no amine inversion, whereas this can show flipping. It can flip around. It can flip like this. Flipping decreases the basic strength. Flipping decreases the basic strength, my dear friends. This is open chain. Yes. So this shows amine flipping. Amine flipping is inversely proportional to what? Basic strength. That's why relatively cyclic amines are more basic than their corresponding acyclic amines. Mark my words. Cyclic amines are more basic than their corresponding acyclic amines due to amine flipping. Yes. So this is it, dosto. Let's move to the next and very important part of GOC, that is resonance. Resonance. The smallest definition of resonance is this: lone pair convert into bond pair and bond pair convert into lone pair. This is the smallest definition of resonance. What is amine flipping? Amine flipping is a concept in which nitrogen flip their lone pair. This is called as umbrella inversion. So lone pair would get distributed at large surface area. They would get distributed at large surface area. That means donating the stability of lone pair would get increased, and it would be donated less compared to the compounds which are cyclic and not able to flip. Is in class 12? Yes, it is in class 11th only. Now next move to the next part of it. Resonance. The smallest definition of resonance is lone pair converted into bond pair converted into what? Lone pair. Resonance. Now there are three major points through which you can identify the compounds having resonance or not. One condition is A double bond B. If you find A double bond B and C position have positive charge, and positive charge means vacant orbital, it should be vacant orbital, otherwise there would not be resonance. Negative charge or lone pair means negative charge only. Lastly, free radical, double bond and triple bond. So if you find any of these conditions, that means it can show resonance. Then A triple bond B, C has vacant orbital, matlab positive charge, lone pair or negative charge, but negative charge means lone pair only. Radical, double bond or triple bond. Lastly, A has vacant orbital or positive charge, and B has lone pair or negative charge. This condition of resonance is called as what? Bag bonding. These are three very important major conditions of resonance. If you find any one of it, that means it can show resonance. Let's have an example. Try to understand. Every positive charge is not vacant orbital. Every negative charge doesn't represent a lone pair. Let's have an example to understand this. Which of the following can show resonance? Which of the following can show resonance? Start writing in the comment box. I'm writing some conditions. Which of the following can show resonance? Which of the following can show resonance? तो आपने मुझे याद किया. A can show resonance. Yes. What else? All. No. All is not the correct option. ACDE. No. ACD is wrong. ABCEF. No. Wrong. RA. China says ABC. Wrong. ABF. You misses 1 point. ABCE. Let's try to understand. This is A and this is B and this is C has lone pair. That means lone pair. This is the condition which we have discussed earlier. A double bond B, C has lone pair. That means it has resonance condition satisfy. Now this is what? This is A double bond B and C has positive charge, but this positive charge is formal charge. This is a formal charge which does not represent any vacant orbital. This does not represent any vacant orbital. So that means this is not a vacant orbital. If it is not a vacant orbital, it will not participate into the resonance. Next is B, boron. Boron already have octet complete with 2 carbon with the carbon and 6 electrons with the hydrogens. Octet complete, that means this is what? This is a formal charge, not a lone pair. That means it would not participate into the resonance. It has 2 single bond. 2 sigma bond between a double bond and triple bond. That means this will not show resonance. This can show and this also can show. That means the answer would be AEF. AEF only. What is the point to raise? Every positive charge is not a vacant orbital, whereas every negative charge does not represent what lone pair. If it is like that, that means this positive or negative will not participate into the resonance. Sir, why F? Sir, why F? Sir, why F? CH2, CH or Cl, it has lone pair. A double bond B, C has what? Lone pair. It can participate into the resonance. Lone pair convert into bond pair convert into lone pair. तो D में क्या प्रॉब्लम है? D में प्रॉब्लम है दोस्त CH2 CH CH2 A double bond B C double bond D. It should be like this. तब तो हो जाता. But it is like this. CH2 double bond CH CH2 CH double bond CH2. So this is A double bond B. C has single bond. So there are two single bond between a pi bond, double bond and a triple bond. So this extra single bond will not make the resonance to happen. It is not clear, sir. Why formal charge? Let me try to make you understand. If it is NH3, it has a lone pair. It was given to H plus. Vacant orbital, it formed NH4 plus. In the other way, it form a coordinate bond with the H. It is donor, that's why positive charge came here, and it has already have a positive charge, so negative charge came here because both the electrons are given to the H. So it is converted into a sigma bond and the positive charge will remain in the nitrogen. This shows that a coordinate bond is formed between a nitrogen and H, and nitrogen was the donor atom. That's why positive remain here. Similarly, BH3 has hypovalent center. So if a H minus goes here and form a BH4 minus, boron gets a negative charge. That does not mean it has a lone pair. Getting my point? So every negative charge is not a lone pair. Usually negative charge means lone pair, but in case of boron, negative charge means just a formal charge. It does not represent any lone pair. Got my point? बोलो 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 बोलो. Is it clear? बोलो आगे चलें. Let's move to the next part of it. Now, how to do resonance. Next point is how to draw RS. Next is how to draw RS. How to draw resonating structure. You need to learn this trick again. If you are confused how to draw RS, this will help you a lot. Electron flow would be like this. Negative charge and lone pair or radical. These two represents what? Non-bonded electrons. Non-bonded electrons are relatively more free compared to the double bond or triple bond electrons, which are bonded with two central atoms. So these are bonded electrons, and this shows no electron. So electron flow would be non-bonded to bonded to no electrons. Two-way slice you miss, sir. It's absolutely alright, no need. Let's start with an example. Let's start to draw a resonating structure of this. This shows lone pair, and this resonance is of lone pair and a pi bond. So let's try to understand. This is a resonance between lone pair and pi bond. So let's start converting into lone pair and pi. That means electron will move towards lone pair to pi. Lone pair to pi. Now, how to make a valid RS? Lone pair will convert into bond pair and bond pair will convert into lone pair. This is the smallest definition of resonance. We'll make two changes. of it and draw a resonating structure, you will get what? CH2 minus CH double bond NH2 plus. Now next part of it is stability comparison, A or B, which is more stable? Tell me, which is more stable, A or B? What would be the answer? Which is more stable resonating structure, A or B? What is the rule to decide the stability of RS? A would be more stable. Why? Why A would be more stable? What are the rules to decide? Yes, A would be more stable. Let's try to understand the rules. Firstly, non-polar RS or neutral RS. Non-polar matlab no charge, and charge is like dukh, grief. So no charge, that means it would be more stable than the polar RS, neutral species. Secondly, you will look for number of covalent bonds or octet completion. Third, you look for closer approach of dissimilar charges. Closer approach of dissimilar charges, that means positive get attracted towards what? Positive or negative, and because of this attraction, energy of the system get low, and which make it more stable. As we know, energy is inversely proportional to stability. So attraction decreases the potential energy of the system, which makes it stable. Or otherwise, distant approach of similar charges. That means positive want to remain as far as possible, negative want to remain as far as possible, and last one is positive charge is more stable on less electronegative element, and negative charge is more stable on more electronegative, which can hold the negative charge or extra amount of electrons. Considering this, you need to apply these rules as per the order. If you will jump rules like 1 to 4, your answer would be what? Absolutely wrong. So before considering or these rules, you need to learn the order. First one is non-polar, apolar, then number of bonds, then closer approach of positive negative, jitna pass utna acha. Distant approach matlab positive or positive, it should be as far as possible, negative charge should be as far as possible. The last one is positive charge is more stable on less electronegative, negative charge is more stable on more electronegative. Let's try to understand this. Compare stability of RS. Compare the stability of RS. Let's try to draw the resonating structures of formic acid. A, B, this is A and this is B. This is C and this is D. What would be the correct order of stability of 4RS? What would be the correct order of stability of 4RS? Let's write in the comment box. What would be the correct order of stability of all 4RS? These are the rules to follow. Non-polar, polar first, and then number of bonds, and then the closer approach of dissimilar charges or distant approach of similar charges, and last one is positive charge is more stable on less electronegative and negative charge is more stable on more electronegative. Considering all these 4 rules, try to answer the question, compare the stability of resonating structure. What would be the answer? Yes, we'll consider the last one. What would be the answer of this? A, B, C, D. A, B, C, D. A, B, C, D. A, B, C, D. So one answer came A, B, C, D. The other one is A, B, D, C. ये मेरे को सही लग रहा है A, B, D, C. I think A, B, D, C. If I were you, my answer would have been A, B, D, C. Let's apply the first rule. First rule says non-polar is better than the polar. That means A is better than B, C, and D. Okay, fine. First rule says A is the best. So this is out. Now second one is number of bonds. Okay, number of bonds 1, 2, 3. 1, 2, 1, 2, 3, 4. Okay, 1, 2, 3. This is 1, 2, 3. That means it has a 4 bond, 3 bonds, 3 bonds. That means B is better than C and D. Okay, fine. Now it comes to C and D. Third rule says a closer approach of positive and negative. They have the same distance between positive and negative. So third rule strike out. The last one is positive charge is more stable on less electronegative. That means carbon. And negative charge is more stable on more electronegative. That means oxygen. That means the answer would be A and then B and then D and then C. Very, very, very correct. C, A, D, R, K, P, G, S. You correctly answered the next question. Let's move to the next question. Compare the stability of this azomethane CH2N2 A, CH2 double bond N positive and negative, B, CH2N triple bond N positive and negative, C, CH2 N double bond N positive and negative, and lastly CH2 N double bond N positive and negative. What would be the correct order of stability? This question was asked in JEE Advanced and JEE Mains both. What would be the exact order of stability? We'll move to the next part of this aromaticity and all. Let's move to the next topic. Before answering this, you should keep in your mind the 4 rules which I have given. A, B, C and D. B, A, D, C. B, A, D, C. Okay. A, B, C, D. Anjali says A, B, C, D. C, B, D, A. A, B, C. Don't jump from rule 1 to rule 4. You can get the wrong answer. First rule first. First rule says non-polar, polar. All are polar. Leave. Second says number of bonds. It has 4 bonds. It has 4 bonds. It has 3 bonds. It has 3 bonds. That means A and B are better compared to the C and D. This is decided by rule number 2. Then next says positive negative should be closer. It has same distance, so the rule gets tried out. It has same distance, rule gets tried out. Last one says positive negative charge is more stable on nitrogen, not on carbon. That means A is better than B. Negative charge is more stable on nitrogen, positive charge is more stable on carbon. That means C and then D. The answer would be A, B, C, D. So this is the way to answer what? Number of resonating stability of resonating structures. The next application of resonance is aromaticity, anti-aromaticity. ये तो हम जानते हैं. We know 4n plus 2 pi electrons aromatic, 4n pi electrons anti-aromatic, and if a compound is not declared aromatic or anti-aromatic, it would be what? Non-aero polar or non-polar. How to find out? Find the charge, my dear friend. This is positively charged, that means polar. If it is not any charge, that means it would be considered non-polar. We are not considering partial charges like C double bond O, partial negative, partial positive. We are not considering it. Yeah. Some other conditions like planar, it should be planar. It should be cyclic. It should have complete peripheral resonance. These are the conditions required in aromatic and anti-aromatic. Now, as we know, if you will apply this in all these compounds, you will get an amazing reply. Amazing. Amazoning reply. Amazoning reply. If you will apply the concept in this sheet of question, you'll get an Amazoning reply. So should we learn it? No, apply the concept, you will get the answer. The most important thing is, if you will see any double bond here, will look like this. Polarize it and you will find out it is aromatic compound. For an example, if you find this, it would be considered like this, aromatic. So this is aromatic, anti-aromatic. Next is what? Resonance energy. Resonance energy is directly proportional to what? Quality of resonance. Quality of resonance. Then if quality of resonance same, then you look for quantity of resonance. Quantity of resonance. For an example, let's have an example A. CH2 double bond CH, Cl, CH2 double bond CH and NH2, which has more resonance energy. The quality of resonance will decide here the amount of resonance energy. Oh, okay, fine. Point taken. I'll clear it. Answered. This is A and this is B. Which would be having more resonance energy considering the quality of resonance? How you will decide the quality of resonance? You can answer it. It is like it has 2p 2p resonance, or it is 2p 3p resonance. 2p 2p resonance is better compared to the 2p 3p resonance. So if chlorine will go for resonance, it will make a bond 2p 3p, whereas nitrogen is second period, it will form a bond through resonance 2p 2p. So 2p 2p bond is stronger one, so that means B would be better than A. So please give example of meta directing group. These are resonating. Let's move to the next part of it. Then I'll answer the meta directing groups. Resonance energy comparison. Let's have an example. If it is given like this, NH2. If it is given like that, OH. If it is considered A and this is B. This is nitrogen and this is oxygen. Both will form 2p 2p resonance. But who will give oxygen or nitrogen lone pair easily? So answer would be given as ease of resonance. Who will give lone pair for resonance easily? Who will give lone pair for resonance easily? Nitrogen has less electronegativity, so it can donate its electron or give its electron for resonance more easily. So answer would be what? Yes, nitrogen. Nitrogen can give resonance easily. Next concept is based on cyclic resonance is better than acyclic resonance. Why cyclic resonance is better? Because in case of cyclic resonance, there would not be bond flipping. Here it can flip. If it can flip, the p orbital will come in plane sometimes, and it would not be in plane in the other moment. That means there are no continuous resonance, no continuous or always resonance, no continuous or always resonance, but it shows always resonance. It shows the resonance always continuous. That means cyclic would be better than the acyclic. So these are some points to consider resonance energy. The last one, let's have an example, a beautiful example of a question like this. Try to answer it. Which of the following would be having more resonance energy? If you will move this positive or negative charge inside the ring, you will get the answer. which would be having more resonance energy. Try to shift this positive charge in the ring, you'll get the answer. If you will move the negative charge in the ring, you will find it aromatic, and if you will move this positive charge inside the ring, you'll get it anti-aromatic. That means the quality of resonance of aromaticity would be better compared to the anti-aromaticity. So this is the way of answering resonance energy. And last one is mesomeric effect. Mesomeric effect can be of two types, plus m and minus m. Plus m, that means plus m means first atom. This first atom, considering A is the first atom, this first atom should have a lone pair. Lone pair. Negative charge, that means negative charge. But all negative charge does not represent lone pair. So strictly I am saying lone pair. It should have lone pair. Minus m has 2 points. First atom A must have a vacant orbital. Positive charge भी बोल सकता हूँ, but not all positive charge shows vacant orbital. So strictly vacant orbital. Secondly, it should have A double bond B or A triple bond B, and B electronegativity of B should be greater than electronegativity of A. Let's have an example to understand. C triple bond N, the example of it. C double bond O H, aldehyde ले लें, ketone ले लें, example of this. A has vacant orbital, CH2 plus is the example of this, or BH2 alone, this is vacant orbital. Positive charge lone pair, example of this is NH2. Some other example like OH. These are example of plus m and minus m. These are donating effect, these are withdrawing effect. Now the question was which are minus m या meta directing groups. Meta directing groups are groups which actually withdraw electrons, like C triple bond N. If electrophile comes, it will attack on the meta position, because they have created positive charge on ortho and para position, so electron density get decreased at ortho and para position, so relatively meta position have higher electron density. That's why every minus m compound is what? Meta directing. Every plus m compound is what? Ortho para directing. Lastly, we are going to learn about some questions, and if a compound shows plus m and minus m both, plus m would be dominating. So these are the example. Let's try to understand the application. We have studied application, that means you can compare the stability of intermediates. Let's try to understand through some questions. When compare the acidic strength, which we will study, acidic intermediate stability, acidic strength or basic strength, these all points we are going to study in GOC2 through some beautiful questions. Let's try to understand the 2020 JEE Mains question. These are the questions. Question number 1, compare the stability of the following alkoxide. Now your turn. I'll sit and see the screen. Who will answer first? The correct order of stability of the following alkoxide is, what would be the order? You can answer through a resonance. You can see the resonance here. What would be the correct answer of this? What is 20 page? What is page 20 page? What is 20 page? I am new. What is 20 page? 20 page organic कब मिलेगा? Waiting. Even me sir. यार मैं प्लान करता हूँ, ये मंथ तो बहुत ज़्यादा वो होने वाला. चिराग says A. Let's try to understand this, guys. This is longer resonance, this shows cross resonance, and this is no resonance. So what would be the answer? Answer would be what? KS says C, so the correct answer would be what? C. Let's move to the next part of it. This is the question which was being asked on my birthday. So this is very near and dear to me. Let's move. Subject change. The increasing order of reactivity of the following compound towards electrophilic aromatic substitution. The ring which is having highest electron density, the electrophile will attack on that ring at the fastest rate? What would be the answer? KS says C, and AG says C, JB says C. Okay. Chirag says C, TP says C. Okay. So this is OME, which shows plus M effect. This is ME, that means plus I and hyperconjugation. So firstly B, and then C, and this shows minus M, and this shows minus I. So that means A, and then D. The answer would be very good. C. Can't understand what happened. SU, electrophilic aromatic substitution. That means benzene must have highest electron density so that electron loving species electrophile can attack on the benzene ring. OME shows plus M. Plus M increases the electron density in the benzene ring, so electrophile can attack easily on the benzene ring because electron density increases. Similarly, hyperconjugation can increase the electron density. Next, minus I will withdraw relatively less compared to the minus M. So relatively, this would be having higher electron density than the minus 1 compound. Last हम बात कर रहे हैं. Arrange the following labeled hydrogen in decreasing order of stability. Decreasing order of stability. This is the last question, guys. Please make it correct so that I can go with peace in my mind. This is the last question. Order of acidity. Yes, my dear friend. Order of acidity. This is carboxylic acid. This is OH, which is having NO2 at the para position. This has OH, which is having NO2 at the meta position, and this is carbon triple bond carbon. Hook, option C. Give reagent list, please. Reagent list 20 पेज वाला आएगा ना, उसमें सब आएगा. I'll try to make it in between March and April. चलेगा? The answer would be D. Yes, sir. When, sir? Yes, sir. When, sir? The answer is D. Let me think. First is carboxylic acid B. AG says B. Then C, because OH has NO2 at the meta position. So C, and then this D, because oxygen has more electronegativity than the triply bonded carbon, as we know in formula 1 and 2, 3. Oxygen is more electronegative than the sp carbon. That means A would be the last. So answer would be very, very correct. ठीक है. So this is it दोस्तों. ये था आज का session. And in next class we'll study hyperconjugation and some beautiful questions of acidic strength, basic strength, and acid base reactions, SIR effect, SIP effect. So okay, we have tomorrow only the class. So this is it, guys. Bye bye, take care, happy Sunday, bye bye.
For detailed videos, daily practice problems and live chat, visit academy.amazon.in or download the app.